All right, listen carefully here, guys. So I'll give you some tips and hints for each question, basically. But here's some that are general. Vectors, significant digits. Remember those on each question. Okay? You don't want to get nickel and dimed on each question because you got the wrong sig dig, but did the whole question right. Okay, so make sure you're making a note of those things. Some of these questions are ridiculously easy. If it's only out of 2 marks, there's probably not very much to do. Don't overthink a 2-mark question or even a 3-mark question. Okay? If it's worth more than that, then obviously there are more steps. So the number in brackets at the end of the question can give you an idea of how much you need to do. All right? Okay, so for question number 1, don't overthink it. Okay? You have a mass, you have an acceleration, you're looking for a force, don't overthink it. Okay? Also, get the significant digits right, or you get the question half wrong. Yeah, just say it. Also, vector, yeah. Also get the question half wrong if you forget that, so yeah. Number 2, also don't overthink that. You do have to do one little calculation, but it's still pretty straightforward, simple question. Number 3 is simply asking, calculate the x and y component of this force vector. Okay, not a question to overthink. Calculate x and y. You know how to do that. You've been doing it for a unit and a half already. All right, number 4 sometimes gives people trouble just because they kind of don't understand what the question is asking. So here's your explanation. This is part A. Okay, this is part B, and this is part C. You have the free body diagram here. Okay, this is the free body diagram for question 4A. Okay, they're all 5 kilogram masses. It's the same 5 kilogram mass. And it's showing you the forces acting in each situation. So each situation is a little bit different. Okay, all it wants is, what is the acceleration, magnitude, and direction relative to the x-axis? No north of east or anything like that. Okay, we want above or below the x-axis is all we're looking for a vector here. Okay, so get your net force, get your acceleration. That's what you're being asked to do in 3 different situations. Okay, everybody with me there? The whole question is out of 9. Okay, so each one's worth 3. Okay, question number 5 is a vector question, but it's kind of backwards. Okay, in question number 5, you have the mass, okay, and you have the acceleration, both magnitude and direction. All right? It tells you that there are 2 forces acting on this mass, but it only gives you one of them. You have to find the missing force. Okay? Now the hint I will give you here is that missing force is not vertical. Okay? People make this mistake, like this force that's directed along the x-axis is the x component. It is not. Okay? The other force is angled. It is not vertical. Okay? All right, number 6 is another one that people, it's like mathematically incredibly simple, but people get lost in the story. Okay? And it's not a good story. It's about a boring spacecraft that can only fire 1 engine at a time. Okay? So this boring spacecraft can only fire 1 engine at a time, and it is currently moving this way at 2,170 meters per second. All right? It is going to want to not do that anymore. So stop, and then go 90 degrees clockwise of that original vector at twice the original value of the velocity. Okay? So what you need to do is tell me which engines need to be fired and for how long each engine has to be fired. Okay, so there are 2 engines that have to be fired. You need to tell me which 2 and how long you have to fire each one. Basically, you're stopping the spacecraft and then making it go in the second direction. Okay, accelerating it to twice the original velocity. That's what you're doing here. Okay, and to simplify the question, the engines are either on or off. There's no throttle. When they're on, they exert 68,000 newtons worth of force. Okay, that's it. Okay, all you have to do is tell me which engines you fire and for how long. So it's probably a bit of an acceleration problem as well. Okay. Okay, number 7 and number 8. We've done a few questions like that. If you go back in your notes, you might be able to find them. Okay, but in both of these, you have an object that is hanging. Okay, and it's telling you the cables, it's telling you the tensions, or asking you to calculate the tensions in the cables. Okay, very much vector related for those two. All right, question number 9. Okay, in question number 9, you're pulling your suitcase at a constant speed, that's italicized, okay, by pulling the handle at an angle. Okay, so that's like if I'm pulling this desk, okay, the desk is angled a little bit, but the desk is only moving horizontally. Okay, that's the piece that sometimes people miss on that question, is that even though the force is at an angle, the box is only moving horizontally. Okay, we may have done something like this yesterday. All right, so what we're looking for there is the angle, and we're also looking for the normal force that is being exerted on the box. Okay, 10 and 11, okay, are both inclined plane problems. Right? Don't overthink them. You know how to do inclined plane questions. Look for clues within the question that might give you valuable information about net force and things like that. Okay. Also, look at what I give you about the box in both questions. Okay. Sometimes people make a silly mistake there, not realizing what they were given. All right. Okay, that covers it all. You've got the whole class today to work on that. If there are questions, you can come and ask, but obviously I'm not going to go, yes, you did that one right. Okay, if you're like way off, I'll probably tell you that. Okay, but otherwise, this is you telling me how good you know how to do this stuff. Okay, it's not an assessment of me being able to tell you how to do it.
When's it due?
I haven't decided yet, but I will.
I really want to work with you.
You can, yeah, that's fine. As long as, with this qualification, as long as you're not like splitting the work. I'll do questions 1 through 5, you do questions 5 through 10. That's not cool, okay? You can work together if you want, that's fine. Okay guys, due date for this is going to be April 3rd.